This is the lecture for aquaculture. It's 8.3 in the AICE Marine Science syllabus. Okay, vocab for this section: intensive aquaculture, extensive aquaculture, 11, fry, par, smolt, trochophore, veliger, spat, growth rate, and invasive species. All right, so reasons why we will have aquaculture to begin with: due to population increase and demand for food, in addition to improving fishing practices, which has caused a plummet in fish stocks. So we've developed efficient ways to improve aquaculture into farming fish and shellfish. Definition: it's the rearing of aquatic animals and plants for human consumption and use. Requirements to have successful aquaculture: we need a food source for growth, and that is also dependent on their life stage, similar with fishing practices and the life cycles of marine organisms. Their different life cycles, especially in a complex species, are going to have different food sources and different habitats. They need oxygen for respiration so they can synthesize ATP. Clean water. They need to remove waste before it becomes toxic, or then you can start to have a harmful algal bloom and it'll have a eutrophication. They need space to prevent competition and cannibalism. And also we'll find that having more space, or at least less species, will allow for less spread of disease. Separating ages and sizes. Small fish being kept away from larger fish due to competition. The smaller fish are going to lose, and then you're going to have a low number of recruitment. They'll also cannibalize each other, and again, they have different food source requirements. And then disease prevention. If you have a high density stock of fish, a large amount of them are going to encourage the growth of disease and the transfer of disease. So things will be used: vaccines, fungicides, pesticides, antibiotics. The pesticides are going to be mainly for your sea lice and parasite infections, because parasites spread really easily in aquatic systems. Ways that we can actually house them or keep them in a contained area. When we use cages, and this will allow for natural water flow to come in, which will flush out any waste, bring in oxygen. It'll also bring in nutrients that you wouldn't have to add yourself. There's ponds. You can take outdoor ponds. It could also be from concrete, and these might be separated from natural water sources, and you'll find that we'll have to actually pump that in and kind of take from the natural environment. Or you could have indoor tanks. These are completely isolated from natural water. Waste is passed through a water filtration system, and this one actually is going to require a lot of work. Okay. There's two types of aquaculture, and it's determined by the amount of effort that's required. Fireworks. There's extensive aquaculture, like external. This is outside. This is aquaculture that doesn't need a ton of technology. They have relatively low stocking densities and no artificial feeding. So all food is going to come from natural water, and we're not going to need to use a lot of technology, like to maintain temperature, obviously, because it's a natural water system, to pump in any sort of water flow or pump any water out, to bring in any sort of pesticides or antibiotics. It really won't be able to be used here. How did I do a firework without it changing the slide? Whatever. These are typically referred to as open water systems. So if I say like in an open system, they're talking about it being in open water. Intensive, this is like inside, internal, and it also requires intensive work, like a lot of work to maintain this. Aquaculture has high stocking densities and artificial feeding, so it's not like they're getting fed fake things. They're getting fed actual food, but it's going to be like given to them, fed to them by people. way more capital investment to start, and you're going to need ongoing maintenance. You're going to need an artificial oxygen supply, so pumping in oxygen. It's not going to come from the natural water flow. You're going to need to add in food. There will need to be water filtration to remove any waste, and medications will need to be used. And these will be referred to as a closed container system. Characteristics of extensive aquaculture. Extensive, this is external, outside. It's less labor intensive. There's less initial capital investment and less like ongoing capital investment, honestly, because you're not needing to have all this excess of technology. No artificial feeding or fertilizers. All that is going to come from the water flow. Low stocking density, which is the amount of fish you have per area. There will be lower productivity and a lower amount of oxygen there because you really can't control that, but lower productivity because they're depending on the natural environment. You really can't control that. You can't increase productivity in any way, honestly, because you are relying on whatever the water brings in on its own. There's low pollution and lower disease because you're in a natural water environment. Little human involvement other than adding and removing the fish, like harvesting them and then placing them in there when they're size ready. Fish that grow really well tend to be really hardy. A good example is tilapia, because they can tolerate a range of salinities. They can tolerate a high waste accumulation. They can also tolerate low oxygen. Mussels and clams tend to grow really well in estuaries on ropes. That will be their substrate because they do need a substrate to attach to, and they'll feed off organic material that's floating in the water. One where you have a couple different trophic levels getting fed at once and helping each other is tilapia is another example. So they can grow really well on rice farms, and there's an example picture right below. Fish are released into these channels, and then they're also going to have the rice growing there as well. The tilapia will feed on the floating plants that are competing with the rice. Typically, it's like duckweed and other floating marine plants. Requires very little maintenance. There you go. And then they'll use netting whenever you're in an open system so that you don't have any predatory birds taking the fish out. A lot of pictures here. It's really fast. So the water from the external source, a tank for breeding, and then filter that out. Okay, so there's a lot involved whenever you have an intensive aquaculture venture. It's going to require more human input, and you need your humans to be trained. That will be mentioned a little bit later. High stocking densities, many fish per volume, because you want to maximize your profits. It's going to cost a lot of money to maintain this. The electricity is going to be crazy, and you need to have a constant source of electricity with that. But you need to be making money while you're doing this. And so increasing the stocking densities just, it's a numbers game. If you're attempting to grow more, then you can sell more, and it eventually will pay, hopefully, for all of your investment costs and your running daily costs. The high stocking densities does encourage the spread of disease. So to prevent that, there's antibiotics, vaccines, and pesticides, and that will be mentioned so many times. In tanks or ponds, water filtration systems are used to remove any waste. Oxygen needs to be supplied. Productivity is really high, but if not done well, and if the water conditions aren't clean and everything is sanitary, and even with the workers, they need to keep themselves very clean too and wear gloves, wear any sort of rubber boots or rubber pants in their outfits so that they're not spreading disease from one tank to another. There's a really high cost of setting up. The day-to-day operations really high, and you do have a lot of loss due to diseases. Semi-intensive, so it's a little bit of both. Semi-intensive does incorporate natural water flow, but there are other factors that humans do control. There's intensive feeding and constant monitoring of water quality. This can cause pollution. Pesticides and antibiotics can be released into the natural water, and that can cause pesticide and bacterial resistance. Food that is not consumed can fall through the cages, and that can actually lead towards like a eutrophication situation, so from a harmful algal bloom due to excess nutrients. Shellfish and fish can escape, and if they escape, this can decrease the natural gene pool. I'll talk about that in a second. They'll compete with native species and become invasive, and they'll outcompete. They will deplete food sources. They can also spread their diseases. So decreasing the natural gene pool, that third bullet from the bottom. Farmed fish are typically very inbred. They are not farmed to be released into the wild. They're farmed for the product they're going to make money for. So it's for meat, for selling. There's a lot of deformities in them, especially within the salmon industry. It's, if a pectoral fin or an eye is a little weird, or sometimes there's a specific deformity where their spine is curved, it's not like they're going to have to really be evading predation because they're not in the wild. So what are you going to do? They're bred because they want genes that allow them to, one of two things: one, grow really fast, and two, be resistant to diseases. So as long as they can do those two things, their deformities are not a massive concern. But they are bred for that. So comparing both types. Extensive typically is very low for all of these other features. Their feeding is going to come from nature. And then intensive, very high. The work intensity is high, and all the effort required is high. They're going to be frequent feeding of artificial food, and it's not fake food. It's just manufactured food, typically from fish scraps, and it's not brought in by natural water. So here is specifically for my students. They have like templates for each type of aquaculture venture, for shrimp, for mussels, and then for salmon aquaculture. For shrimp aquaculture. Breeding in hatcheries, they're bred indoor. The larvae are going to feed, because their larvae are zooplankton, so they're going to feed on smaller zooplankton and then and algae as well as they get larger. And their other larval stages, they're going to feed on zooplankton. Disease outbreak is very common. They lose a high percentage of their larvae to disease. Antibiotics and pesticides are included in their food. Despite frequent cleaning, mortality is really high. Then they go to a nursery. Similar to like how this would be in real life, they breed within the open ocean or at the seafloor. Those eggs float to the surface, and then they're going to make their way, as they start to metamorphose, they make their way to a nursery that would probably be like a mangrove or seagrass beds. So post-larvae will get transferred by rail to railway ponds. They're just long, very elongated ponds, and it's separated by age. There's a constant water flow through the tanks. Temperature and salinity are regulated. The shrimp are fed a really high protein diet for about 3 weeks, and then they'll go out to grow out ponds. These ponds are blocked off areas of coastal water. So it is estuarine, which is going to be what they're going to be adapted to and what they would normally live in nature with. They'll live there for 3 to 6 months, and then shrimp will be fed until they're market size. When they're harvested, the ponds are drained and cleaned, and then the shrimp are removed with nets. Keep moving my face. 2 types, so very different. We have some semi-intensive right here where they're putting this near the coast. They can be pumping water in, and then definitely intensive towards the bottom. Extensive systems for shrimp. This is about 10 to 20% of shrimp farms. There's a low investment, low stocking densities of wild larvae. Because this is extensive, the investment cost really isn't as much as intensive. They're going to be using a lot of the resources that's coming from nature. They're in a netted area of mangroves or coastal waters. Seawater circulates with the water, and it's going to bring in food. It's going to clean out any waste and bring in oxygen for respiration. The yield, or what you're actually going to be able to sell, is relatively low because you can't just increase the oxygen content so you can do respiration and grow. You can't add in more food. You can't add in a bunch of growth hormones or anything like that because it's open water. You really can't control it. So yield is low, cost is low, and the disease is low because there's not such a high stocking density to spread it around. The skill set required to do this is also low. Semi-intensive is 25 to 30% of farms. And I want to go back to extensive. It's good that it's only like 10 to 20% because this, if you remember from AS level, and then they may ask this again on paper 3 for conservation, why so many mangroves might be destroyed or ways you can start to rehab it. One of them is from shrimp farms. The semi-intensive, this is separated from natural water. They might pump in natural water, but it's not necessarily attached to it. It's separated from natural water flow. Water is going to pump and circulate water to remove waste. There's a higher stocking density, so more food is required, and this is something humans have to do and feed them on a schedule, specifically their amount for their size. Productivity is high, and the cost is higher. And you have to pay humans to do this, so the cost will be higher because you have to pay them. 55 to 60% of shrimp farms are intensive. So indoor, they're isolated from nature. Shrimp are bred on site. The stocking densities are really high. The disease is really high, so antibiotic use is really high. Water and oxygen have to be circulated. Again, artificial food is used, and then productivity is high, operation cost is high. And in order to do this right and not screw it up and waste money, the skill set needs to be high. For salmon aquaculture, this one you're going to see definitely separation of ages and separation depending on what type of water they usually live in. Where salmon spend the beginning of their life in freshwater, and then as adults, they'll live in the ocean. Production of broodstock. Broodstock is your reproducing stock. You don't want to be taking this from the ocean. You want to maintain like your mating pairs. Males and females are selected from open water cages. They're placed in separate freshwater cages. They're fed a high protein diet so they can make sperm and egg. In highly intensive methods, reproduction might be encouraged by changing the hours of light exposure so it can mimic what would be like in the wild, or they can add growth hormones. Get my face out of there. For spawning, females are shifted their eggs into a bowl of water, and you see that one right here. The male sperm is ejected into the bowl to fertilize it, just like so. Unfertilized eggs get disinfected. They're placed into trays of fresh water. Fertilized eggs get disinfected and placed into trays of fresh water. You don't want them all piled up on top of each other either, because then some of them, like the ones at the bottom, are not going to be getting as much oxygen. It could decrease their growth. Unfertilized eggs are removed, and this will prevent bacterial growth. Hatching. The eggs are left on trays of cold fresh water in the dark. This should mimic the freshwater riverbeds that they do develop in. Stones are placed at the bottom to mimic conditions of the riverbed. The hatchlings will emerge to the surface, and then food will be added. These are called 11s, like the number. So you can remember that this is the first actual stage of the salmon, aside from a fertilized egg. It's the first stage, and the number 11 has a 1 in it. So every stage will have separate living area and food source. In a nursery tank, the 11s will develop into small fish called a fry, and that might be why people will say, oh, look, it's a fish fry, or it's a small fry. A fry would be something that's small. They're transferred to larger tanks. They're fed more amounts of food. So they're getting bigger, they're going to a different area, and their food is also going to start to change. They grow in a closed system, so we're not having, there's no chance of predation. Everything is going to be artificially or like man-made, put into their system for what they need. Nothing is from nature. Water circulated, temperature will be regulated to control their growth rates. The fry continue to grow, and they will turn into what's called a par. They'll be that way for 3 years, and then they'll go to outdoor lake cages. Par are called par because they have par markings on them, which look like dark spots, and that helps with camouflage in a freshwater riverbed, which would be their natural environment. When they are big enough to become a smolt, they go to estuaries, and estuaries are not going to have a gravel bottom like the riverbed. Smolt become more elongated, and they're silver. And that's a way that I remember it. The par is par markings. 11 is the first stage. And after the par, it turns into a smolt. And I would say like the silver smolt, because they get silvery, because it mimics like the water that would be reflecting off of the light that's reflecting off the surface of the water. So light will like hit them and also reflect. The silver smolt goes to sea. The silver smolt goes to sea, but first it's going to spend some time in an estuary. When adapted to saline conditions, they can go to the ocean, and that's where they are going to metamorphose into their adult stage. Growing out in seawater, the adults will live in open cage systems. This is actually really prevalent in the northern parts of our country. So in the Northwest Pacific by Washington State and also like British Columbia. So not our country, but still north of our continent. The adults live in open cage systems, so you have some freshwater flow. There's platforms for workers to feed them, inspect them, and harvest them. Natural water currents will remove waste and provide oxygen. Also will help maintain salinity. They're fed high-protein pellets from scraps of other fish catches. So that is way more sustainable. The scraps from other fish catches are ground up and kind of like put into, could be in like a pellet, and then fed that way. And they're in a cage system, but it's more of like a net. Feeding is automated so that they prevent overfeeding, and then water pollution. Antibiotics, fungicides, pesticides, and vaccines are added. The age and the size of the fish are placed into separate cages. Just kill a bug. My hero. Pigments are added to their food to give them a pink hue. Great. Harvesting. After 2 years, they're transferred to slaughter so that they're stunned and they're bled and then processed. Unused fish parts will be processed to form more fish pellets so they can have a high protein diet for the future stock. And some of these adults are retained for future breeding stock. We call them brood stock. The salmon life cycle. So the adult is going to lay the eggs and then deposit sperm on it. Our first fish stage, we have the 11s, and then a small little fry, par with the par markings. The silver smolt goes towards sea, and then the adult. Mussels. All right, so at the bottom, we are going to start with broadcast spawning, external fertilization. Fertilized eggs will turn into trochophore larvae. Trochophore, I think that might be the weirdest word you have throughout this. The trochophore turn into veliger larvae. They're called this because they develop this velum organ, and essentially it's like their entire being. The velum organ helps them with swimming, gas exchange, and feeding. It does it all. They're going to settle and then begin to metamorphose. Once they settle, they're spats. And I remember that one because if you spit, it's going to land down. So this is when they start to settle down. They land on something. However you learn, it doesn't matter. And then number 5, they develop further into adult mussels and they continue to grow. So the stages for this method then, this is the life cycle. Stages are over on the right. We're going to seed the ropes with the spats. We're going to put them in a coastal environment to grow out, and then we can harvest them and process them. So first over here is seeding of ropes. The ropes are made from coconut fiber, and they get seeded with the spats. The spats are very small. And you have a picture of it here. In extensive aquaculture, the spats will attach themselves naturally if you place ropes near a mussel bed. Intensive, mussels are fed algae in tanks. The light and the temperature are changed to induce spawning, and then once the larvae are past 10 millimeters or 1 centimeter in a nursery tank, they're placed into the sea. For growing out in coastal water, there's a few different methods. Some of these are referenced on exam questions. I know like the Boucher method is. Long line rope method, all of them are essentially a little bit of the same. So ropes are hung off long lines that are suspended by buoys. Takes a big boat to take them out there to do this. The boucher method, ropes are coiled around wooden poles that are embedded into the sea. Raft method, the ropes are hung from floating platforms. Seeding and growth occur in this method. Seeding and grow out will occur in this method. So the floating platform, it's very similar to like your long line, but one's a raft, one is anchored or floating by buoys. For harvesting, in about 12 to 15, impressive, hold on. Months, that makes sense. I didn't think it was going to be weeks. About 12 to 15 months, they're ready for harvest. The mussels are stripped off those, the ropes that they're attached to. They're washed, they're clean, and separated before they're packaged for sale. And if you want to watch this on your own, it's by Noel Farm. Billions of mussels raised by this modern technique. Buoy method. Why is it needed? Reasons for aquaculture, and I could see this as like describe 3 reasons why aquaculture is needed. So we don't want to say because the population increased. Like that's a statement. If the population increases, why is this needed? So to conserve wild fish stocks, we stop taking food from the ocean, and we can apply pressure other places, like growing them specifically for this, to repopulate wild stocks. Provide food sources for human populations so they can have more protein in their diet, and obviously to make a profit. No profit is made. Business is not sustainable. And we can see then for the past like 24 years, we've had a lot of growth in aquaculture. Basic requirements will be on the next slides. So for these to be successful, they're going to need availability of fish to stock, clean water, availability of feed for the fish, and it has to be efficiently used. We can't just be taking food from the wild to give to farmed fish, because one of the things we're trying to do is conserve wild stocks. Having labor that's available, because not anybody could just do this, you should be trained. Disease management, we need to have a location that's available. Demand for that species that is being farmed. Access to a market to actually sell it. And sometimes international laws will stop this from happening too. And then some ROI, return on your investment. So availability of stock. You need a starting population. So you can either get this stock from maintaining a population of male and females that you already have and not slaughtering them. You could buy fertilized eggs or larvae from another company, or you can remove juveniles from the wild, but that's negating what we're trying to do. Majority of fully intensive farms will breed their own stock and keep that mating pair, although they're not really mating because it's not like they choose their partner. Clean water, because you need to have less disease, and you need to remove toxin buildup. In extensive systems, this is natural water flow. In intensive systems, constant running water is needed. You need to have a filter system to remove waste. Availability of food. Fully extensive systems, no need to worry about it because it comes in from currents and tides. In fully intensive systems, food must be added to maximize growth rates. They give a little bit of food often because you don't want to overfeed. It'll just sink. And if it sinks away from them and they're in like a netting system, they're not going to go to the bottom to get it. They can't. And this will help their growth rate. So growth rate is one of your definitions. Rate is always a speed, an amount of something over time. So the speed of growth of a population in terms of its numbers, so the amount of fish that you have or the individual sizes that you have. And the food source needs to be sustainable. So protein pellets from fish scraps is most sustainable, not taking food out of the ocean to feed farm fish. Predatory fish aquaculture, like the bluefin tuna, needs a lot of fish and shellfish because they are a top-tier predator. By top tier, I mean trophic level. The food source should not come from the ocean. If food sources are farmed, though, they get more expensive because they need a lot of it, and they need not just like bait fish. They need a natural food source for themselves. Tuna are highly active prey, and they're expensive to feed. They're also expensive to maintain in their net. Sometimes they get caught in the net. They swim really fast. And their food, like I said, is from higher trophic levels. The investment is typically not worth it. Efficiency of feeding. In extensive systems, there's no food waste because, again, we have natural water flow. So I said there will be a lot of things that are reiterated over and over again. And I mean, nothing wrong with repeating, but there are a lot of things that are reiterated. In intensive farming, feeding systems must be sustainable. If they're underfed, growth rates will fall, and you're not going to be able to sell very large fish. Profits will go down. If they're overfed, you're going to waste food, and you're going to then waste money because you spent money to have that food. And additionally, you're going to have pollution. Again, that can cause algal blooms and then eutrophication. So it's best to give a little bit amount over time and then maintain your growth rates and record them. You could do like random sampling of these fish to at least record how their growth is going. The type of food is very important. It varies by species. You don't want to just give every species one size fits all diet because for some of them it's not easily digestible. If it's not easy to digest, you're going to have more fecal waste and there will be slower overall growth. Disease management. In high density populations, so in your intensive systems, this will increase the spread of disease because they're so close together. How they manage it, there's antibiotic use. This will suppress the growth of bacteria. It's expensive and it will create bacterial resistance. So it's not going to kill, right? 99.9%. It's not going to kill every single bacterial species and bacterial organism. The ones that survive are going to be stronger and they are resistant to it. And a common one is this bacterial gill rot. Fungicides and pesticides reduce funguses that grow on them and parasites, which are the pest. These could leak into the environment and again cause the same situation, cause resistance. A common one is ick. It's this the white spot disease on them. And this is parasitic sea lice. You can see all over it. And it's just literally eating the fish tissues alive. A lot of times they have them in their gills too, or like on their eye. Vaccines will help them develop immunity to viruses. And in shrimp aquaculture, even though they try and keep it very clean, you got a shrimp down here on the right, the mortality rate of their embryos will reach 60% because of white spot disease. Availability of location.
Sri Lanka's largest aquaculture firm, Senura Aquaculture Projects Lanka Private Limited, is inaugurating the stage 2 of its operations at the state-of-the-art aquaculture farm at Ambakandavila, Chilau on 18th of May 2014 by the auspices of Minister of Fisheries and Aquatic Resources Development, Honorable Dr. Jita Senaratne. So availability of location for extensive aquaculture, you need natural water. It's accessible for harvest and suitable for the species you're trying to grow. It has an appropriate food source coming in with currents and tides. It has a suitable substrate if necessary. Some of them have to attach themselves. The water has to be a suitable temperature for growth. And as farms expand, coastal habitats like your mangroves could get destroyed. For intensive, you need an area where there's trained workers. There's more cost to operate the entirety of it. Larger area of land because you need to now build these ponds and tanks and areas for the water filtration systems, more pumping stations, filtration units, storage facilities for equipment, and then access to constant source of electricity. Availability of labor. You can just have anybody do this. So extensive systems, outdoor, more natural water flow. You only need human input when you're setting this up. Has minimal maintenance at the facility because, again, natural water flow is doing this, and then you need some help whenever you're harvesting. In intensive systems, you need both a lot of people and increased level of skill. For breeding, maintenance, there's a lot of technology involved.
feeding the fish or your shellfish and processing. And as your business starts to grow, your staff is going to grow. People like to be led, people like a leader, and there will be more levels of management. Training can come from a lot of different sources, and this is just a handful of it. There is a program even at FAU. Market demand. There has to be desired. So if your market doesn't want it, then you're wasting your money even doing it. The profits have to be greater than the startup cost. If demand for the product is high, you can increase the price, obviously, and the profits will be high. If the demand is not as great, but your production keeps going up, then your price will have to fall. Access to actually sell it. Aquaculture has to have access to fish markets. In order to export these, there has to be a transportation network. So this can't just be placed anywhere. And if it is, you need reliable transportation for them. Roads, trains, and air transportation. So close to an airport, close to a train station. Fish and shellfish will spoil really fast. They have to be transferred really soon after harvest because you can't really worry. You can't really consider a bunch of delays, like in weather. It needs to be sent out soon. Asian countries want live fish. So they need to be transferred really fast in cold water with refrigerated trucks and being really close to airports. And then imagine if you want that to stay alive while in an airplane, there's a lot involved, and that would be associated with the cost. So aquaculture is very limited in more remote locations. If they want to then expand and they still want to go with the business plan, then you need to build roadways, transportation networks that will cause loss of land. It's a lot of money, and it's going to cause some pollution, of course. Got to have a good ROI, your return on investment. So this kind of parallels with CPUE, the cost per unit effort, like how much you're going to put into like fishing a certain species. Now it's how much are you going to put into farming a certain species. It has to be worth your time and worth your money. The initial cost to start this business is going to be really high, and this is mainly geared towards like an intensive venture. You'll have ongoing replacement costs, updating equipment. That will be an ongoing cost that will occur too. A country that is farming fish, so for example, like America, there's a high value currency, so money's worth a high value, then exporting the fish to other countries is going to be too expensive for them to get. Importing raw materials will become cheaper though, because then your more value country a higher value currency will be able to afford it, getting it from a cheaper country, just because the prices are much cheaper. If a country is a low value currency, then exporting the fish is much cheaper for other countries to purchase. So like we might get our fish purchased from other countries that have a lower price value on their dollar, on their paper money. It's easier to sell internationally though. But if they need to import raw materials, it might be too expensive because they'd be getting it from a different country, hence the import. Here's an almas ocetra. I don't know, I'm not rich. On Amazon, it's $485 for the ounce. It's caviar. It's one of the most expensive caviars. It's crazy. Most expensive fish ever caught, and I fact checked this still stands. 2019, a 600-pound bluefin tuna was caught for $3.1 million. Crazy. But likewise, when the global economy is good, more money is spent. You can spend more money on luxurious thing, and you can farm high-end fish. When the global economy is poor, there's less disposable income to buy your $500 caviar. You can even do subscribe and save on Amazon. Get a little bit cheaper. And there's a high demand for less expensive fish. So it kind of depends on what your market's doing and what kind of fish you're going to choose to farm. Potential impacts. This will also be repeated from some things I've already said before. You have habitat destruction, overfishing of feedstock, pollution, invasive species introduction, escaping of your stock, spread of disease, competition, and the main goal is just to reduce fishing pressures on your native fish stock. Habitat destruction. So it does require land development. Having an intensive or even a semi-intensive aquaculture, this will cause loss of habitats, period. Intensive shrimp farming systems use cages that are built into coastal areas, led to loss of mangroves. There's lower biodiversity, of course. You're going to have loss of nursery ground for wild juveniles. That's what mangroves are great for. And they're great for us for protecting the shoreline and reducing the impact of storms and erosion and storm surge. They're also like great friends with coral reefs because mangroves will slow down water currents and allow sedimentation to occur, and not so much sediment is taken out in the back end back towards the coast. And you don't want sediment to smother your coral polyps or reduce light penetration.
Fish farming uses wild fish to feed farmed fish, but it kills more than it produces. All of these anchovies will be ground up for fish meal to feed fish and other animals around the world.
Of the 100 million tons that get fished every year in the planet, 40% go and get ground into fish meal to feed other fish and not to feed people. So that some rich people somewhere in the world can eat salmon and can eat shrimp.
The more fish farming we do in the West, the less fish we have. This is one of the paradoxes that people have problems understanding.
Okay, this is from a documentary called End of the Line. Fully extensive farming utilizes natural water, so there's no need to be taking the food source for fish out of the water. There's no overfishing of feedstock. Feedstock is like food you're giving to your fish, your farmed fish. Intensive farming requires a lot of food, and in many cases, food is harvested from the oceans, and then you have me saying it doesn't make sense, because one of the goals of aquaculture is to minimize the impact on wild species, so fishing out of stocks to feed farm stocks is unsustainable. Pollution is a big one. She's a big one. Extensive systems are less polluting. There's not additional feeding. There's not additional antibiotics or pesticides or fertilizers. But semi-intensive is very polluting. Extra food and fecal material can lead to eutrophication and cause oxygen depletion, hypoxic areas, or even anoxic areas. Fertilizers can leach into the water, cause eutrophication. Pesticides will kill parasites, but they can also kill native species or make the parasites that do survive much more resistant. Antibiotics and antifungals can affect your natural bacteria and fungi, and they can become resistant as well. In intensive closed systems, so this is not connected to a natural water source, they need to be put into like the water in the fish is in a sealed tank, but the water should be filtered before it releases the ocean. And when I was looking for GIFs to put in here, here's what I found. So that's where I said at least it should be. A salmon farm in British Columbia seeps blood from their salmon processing facility, and that also releases a lot of viruses that the dead salmon were carrying into the water, and that it affects their native populations. So that's great. Introduction of invasive species. So if you have your farmed fish escaping, then they can become invasive. This will cause harm to the ecosystem and cause ecosystem imbalance. Invasives will outcompete your native species, and they can bring diseases. Again, they can also mate with your native species, and they're bringing not the strongest genes to the table. So it can cause genetic weakness in the wild. And fish are farmed for different reasons. It's not because they're really great in the wild. It's because they're resistant to diseases and they grow fast. This can also happen. So a storm could cause this. This did happen in Washington in 2017. Oh gosh, it's time for yawning. 305,000 salmon were released into the wild, and just clicking through some of these pictures a little bit, I found that there was some litigation between this happening. So this is what it looked like, and then what happened after. Competition for resources. In intensive systems, and if it's done inland, they're going to need a lot of water, a reliable source to constantly pump in and pump out. diverting large volumes of water will cause competition with the local environment. If large quantities are taken from lakes and rivers, this will cause less local plant growth, lead to less productivity. This is a bunch of pipes in Taiwan. This is gross. All the sea lice on them, all these little circles you see. Sad, yeah. On their eye. Ah! They need a cleaner wrasse. They don't live there. So high stocking densities. One species will cause the development and spread diseases. $6 billion a year is lost by disease in aquaculture. In open water cage systems, there is a risk of disease could spread to natural populations. Sea lice that will feed on salmon skin, mucus, and blood will kill them and literally eat them alive. And they will have, if they're not killed, they're going to have slower growth rates because their body's going to spend so much time trying to regrow what's been destroyed. So pesticides, fungicides, antibiotics, and vaccines are usually used to stop the spread of diseases and parasites and illness. So the main goal is reducing exploitation of native fish stocks while making a little bit of money on the side. Farm-raised aquaculture, I'm going to say the same thing again. Right? So farm-raised aquaculture should meet your consumer demands. And so there needs to be a demand for the fish you're farming. It should allow the pressure on wild populations to decrease. And if we do this with fishing restrictions and fishing intensity brought down, we do have the potential to satisfy customer demands and preserve wild stocks. So then the remaining slides is going to be how do we go about stopping these negative things from happening? And we've already mentioned some of them. For pollution in closed systems, solid waste like fecal material and food will settle. It can then pass to an anaerobic decomposer, so decomposing without oxygen, and it produces methane gas. This is used as an energy source. Yay. This is a great one. This is a great one. This one makes most sense. This makes most sense. So having a multi-trophic aquaculture system or a zero waste system, this is the best. This is the best because you are ultimately not having to have all these additional things brought in and artificial things brought in, and you're still going to make more money because you're going to be farming more species. And they're all going to work for you. The system will generate less pollution and more money because you're growing more organisms. If we start with our fish are going to have excess food particles and fecal material. Our crustaceans and detritivores will be able to eat that. Excess food, excess feces, any extra minerals floating throughout the water will be taken in by the algae on this top rope and then used to assimilate into the biotic cycle through photosynthesis. Mussels will be there to just clean out the rest of any of the particulates and filter feed through the water. But then you can sell the algae, the mussels, your crustacean species, or the detritivores, and down here is also a sea cucumber, and then obviously the fish. Sustainable use of food and water for your species instead of disposing through sewers and pipes. If this is done inland, they need to recycle the water and put it back into rivers and lakes, and that will also keep the competition with the locals down a bit. Carnivorous species like tuna should have discarded fish parts from human diets to make protein pellets and fish meal. And again, also like parts of fish that aren't being processed, but that helps minimize waste. We waste so much food. So much food. Plant species that are going to, like soybeans, barley, corn, peas, those can be reused to make feed pellets. This would be for your herbivorous and omnivorous fish and shellfish. So a lot of this reusing of food parts. Preventing escape. Went too far. So farm species should be isolated from natural water by using tanks or closed pools, not nets. Cages are used. There should be strong netting with an appropriate mesh size, but they're easier to be damaged. The production of exotics in a cage system. So a species that is 100% going to be invasive, it really doesn't belong in that area, should be not in contact with natural waters at all. And if they are, like, keep it away from MPAs or any sort of protected area or reserve or area where you already have an endangered species there. To reduce disease spread, reduce stocking density, just don't have so much per area, then you're not going to have as much organisms to spread diseases to. So this also minimizes the need for pesticide, antibiotics, fungicides, vaccines. It'll save cost. This will, well, it's hit or miss because you're also reducing the stocking density. So this will reduce pollution and it'll stop disease resistance. To stop habitat destruction, just stop it. Just don't do it. Write that. Having input from community stakeholders. So not building on marine reserves or any marine protected areas. Not building on nursery grounds or any biodiverse habitats. And the community input matters. You don't want to have it in a place where maybe like you're making a ton of money from tourism. It's not necessarily going to be a good look. It's going to smell kind of bad. It's going to look a little bit industrialized, and it will negate from tourism in that area. 2 slides left. Positive outcomes for the social impacts of having aquaculture. It's job opportunities, especially in areas with low employment. It will employ a lot of people, and especially as that business starts to grow. Provides more money for local people. They will gain skills they can transfer into other sectors and maybe skills that they can move other areas with. And anytime that there is more money for local people, it's going to benefit the community at large, right? There's more money to pay into taxes. That's going to give better infrastructure and better services and just better resources for the people in that local area. There will be improved secondary services. You'll have more transportation opportunities, more housing construction. There will be more restaurants, there'll be more retail just because there's more people there. That area will generate more money from exporting fish, and that's going to be more money for the community. If this area has low wealth and possibly malnutrition, they're now having an accessible source of a high protein food. And as business grows, this is also, again, like another secondary thing. More people move in the area, there will be more housing, and more people are going to purchase goods and services from local businesses. But where could it go wrong? This is our last slide. Tourism could decrease due to smell and unsightliness. It's ugly, gross. Land loss, pollution of habitats. Some can actually cause more unemployment. If the feed for your farmed fish is taken from wild areas or from the sea, this will decrease your local fish stocks. It'll decrease the yield or the catch of local fisheries. Those fisheries could fail. They could be mad. You don't want all your different stakeholders to be upset. This could put more pressure on housing as well. So the population could grow too rapidly, especially if there's a lot of jobs available and you don't have any sort of infrastructure or schools available or just maybe public transportation methods. There's just not enough. There's not enough housing. There's not enough medical care. You don't have enough water and sewage infrastructure. So that could also cause a lot of stress in the area if you just grow too big too soon. Something that I don't think we think about that often, very fortunate to not necessarily think about, but the increased wealth of one group of people, and it might be a lot of people in the area, but the increased wealth of one group of people could cause local prices in general just to increase in that area. And goods and services are going to become too expensive because everyone's going to want a little piece of the pie. And if there's a group of people that have a bunch of money, like businesses might exploit that by increasing their prices, but that might be a deterrent and a negative situation for other groups of people in the community. And that could just cause them to have like a poor taste for the aquaculture business in the area. How do we prevent it? keeping your community involved and keeping your main stakeholders involved. If they feel like they have a say in it, same with fisheries and putting on restrictions. If they feel like they're valued and their opinion matters and they have a say in it, they're more likely to support the business and find, common ways to agree and work out both parties' desires. Having careful employment of the workforce, so not hiring people because they're cheap, they're easy labor, and you just need somebody who can do cheap, easy labor. Like, that's not going to be great for your business. Actually employing people who are skilled in these areas and trained in these areas will allow this business to be more successful and taken seriously, but you will have to just pay them the money that they're worth, which that is never a problem. Time and time again, we see businesses actually pay their workers worth what their value and what they're good at, and you typically get much more productivity and better work from those workers. Oh, I did this in under an hour. Incredible. And thanks for coming along. This has been Aquaculture. Good luck on paper 3.